Okay, well, good evening, everybody. My name is Dave Rauch. I'm Director of Admissions at Springside Chestnut Hill Academy, and thank you for joining us tonight to learn more about really one of our premier programs here, our Robotics and Engineering program. Just to give you a basic overview of really how the night's going to run. In a moment, you're going to hear from Peter Randall, who runs our Robotics and Engineering program here at the school. He happens to actually be a graduate of Chestnut Hill Academy. I'll not let you know what year he graduated. If Peter wishes to share that, he can. And then you'll hear from some of our students. He'll tell you a little bit about sort of their experience, what they're working on. And then some of you have been kind enough to submit some questions already. If you have any questions too, as we go along, please feel free to go ahead and drop them in the chat. But without further ado, it's my pleasure to hand it over to Peter.
Good evening, everyone. Yeah, thank you very much for coming out tonight, if only virtually, to see what we have to offer. As Dave mentioned, I am a graduate of CHA, one of the predecessor schools. My wife is a graduate of Springside School. The other predecessor, our two sons both graduated from SCH. And this will be my 66th year on campus, which sort of puts everything into perspective. It has been my pleasure, along with Rob Ervin, who I'll introduce in a little bit down in the lower left, to have started the SCH Academy. And I think it's one of the programs that truly distinguishes our school from others that you might be considering. Sort of the key to our approach has been we start young, we start in first grade, and we do it all through project-based or passion-based learning. So I like to tell the kids, no tests, no homework. Thumbs up from the kids, no tests, no homework. Okay, but they'll work really hard when they're in our space because they're working on stuff that they're passionate about. They're working on stuff that they find naturally engaging. They're working on stuff that they care about. And that allows us to contrive projects that have the combination of being not only engaging, but they're generally fun. We build an awful lot more race cars and airplanes and model airplanes and sailboats and so on than we do septic treatment plants. They tend to be fun. They tend to be engaging, and they tend to be hard. And that's what we're looking for. We're looking for the opportunity to give kids a chance to try something that is difficult, that they have a high probability of experiencing some failure along the way. We want to make sure that the kids develop a resilience and persistence that allows them to be successful both through college and later in life. And they do that by experiencing setbacks and being able to overcome them, try again, and so forth. So I mentioned we started in first grade, we do, and we do that primarily through our CEL program, the Center for Entrepreneurial Leadership, which allows us to engage kids in a variety of projects that tickle their mind and them to explore things outside the typical academic curriculum. Moving up into middle school, we teach a series of courses, again, through the CEL program around the Lego Robotics Program. We just had a regional qualifying tournament for the Lego competition this past weekend, and I'm happy to say that two of our sixth grade teams moved on to the regional championship. That's very exciting for us. And that gives kids an experience both in terms of mechanical design, but also in terms of programming. Moving along, when we get to the upper school, we do a series of courses again through the CEL program, which have the unique feature of being required of all students, but they're pass-fail. So they, again, no tests, no homework, and we encourage them to pursue topics that they might not otherwise take a chance on. So for example, I teach a ninth grade course in microprocessors, and we teach kids how to design circuits, how to program them in the C programming language. They can take that experience, that skill set on into further projects in their sophomore, junior, and senior year. Junior year, every student takes what we call the Cel Capstone Program, where they are able to design a curriculum of their own choosing. They can write an opera, they can open a business, they can start a nonprofit, or they can build products or other objects that are of interest to them. A good example, last year, one of our students built a remotely operated underwater vehicle, theoretically capable of diving to 900 feet. It's pretty impressive. Of course, the cable is only 200 feet long, so it won't get that deep. But it was a pretty impressive project. 2 cameras, 2 computers, pretty impressive project to pull it all together. And he's still working on that in his honors engineering class, where he's designing manipulators to allow him to pick stuff up that he sees on the bottom. So moving from the CEL program, again, everyone takes that. We have a series of design electives and engineering electives in the upper school, starting with computer-aided design and manufacturing. So we ask the kids to design three-dimensional objects using computer software. We use a product called Fusion 360 from Autodesk. And in addition to the sort of the traditional mechanical designs that we build, we also venture into some of the more eclectic stuff. This is a three-dimensional frog designed by a student, or one of my favorites, a very impressive lion. These are actually very difficult to design because they involve non-geometric shapes, which are harder to do on computers. And so it's a skill set we want the kids to be able to master as they move on. We go into a series of elective courses where we call them design build courses, where they pick a project and then they design it, fabricate it, build it, program it if necessary, and they tend to be fairly large projects. If you look behind Hannah, you'll see the outlines of an airplane. We have a group of kids that are in fact fabricating a single-passenger, a 4-passenger single-engine airplane in our lab. We have Ryan in front of an elf. This is a solar-powered recumbent bicycle. Tony is working on a project to fabricate a video game. He took the challenge of, you can play video games in my classroom if you make them, quite literally, and has designed and fabricated a video game of his own. So the idea is to give these folks a challenge, again, hard, fun, and engaging, and then letting them run with it. So we spend most of our time standing next to our students, helping them solve their problems, not much time standing in front of them, talking at them. And I think that works quite well. We also do, as you may be aware of, an after-school competitive robotics program. Again, starting in first grade, our first graders all through sixth graders competed last Saturday. And as I mentioned, 2 of our sixth grade teams are moving on to the regional championship. And these are all primarily Lego based. In the 7th and 8th grade, we move on to, and I'm going to swing this around, to what's called an Ftc robot. These are fabricated robots. And you can see we have 2 examples here on the work table. Mr. Ervin is leading that effort and has come up with a pretty exciting design. I'll let him talk about that in a minute. The end result is that we put about 15% of our grads directly into engineering school. And they're going to places like Princeton, Penn, Cornell, Columbia, Brown, Johns Hopkins, Carnegie Mellon, RPI, WPI, RIT. My son's down at Virginia Tech. Rob's 2 sons went to Penn State Engineering. Tony's older sister's down at Johns Hopkins Engineering. So we have a pretty good track record of putting kids into some of the top programs around the country. All 3 military institutions. We have kids flying jets for the Air Force. We have kids designing ships for the Navy, and kids working for Tesla, for SpaceX. So they're finding success from learning to love learning hard stuff because it's more fun. Here, that is our mantra. Hard stuff is more fun. It's also more rewarding. So we want to lay that challenge in front of your kids and help them achieve that. So with that, I'd like to sort of ask Rob to jump in and talk about his role in Ftc and Frc. Rob helped me start this program 20 years ago. Took an 8-year sabbatical to work at AIM Academy and start their program, and has just returned to SCH, back to the home stomping ground. So Rob, say hello.
Well, hello, everyone. Nice to be here. And my job is to support the students in their role. I'm the resident engineer. And so when they come up with these wonderful and sometimes crazy ideas, it's my job to sort of help them figure out how to do that. And it's really the key part is help them figure out how to do it. I've built plenty of robots and I have a lot of experience, as does Peter, but it's really letting these kids and students try and fail. And some of them come to us never having used a Phillips screwdriver or even knowing what that is. And by the end of this program, we're building, we're creating, we're having ideas, and we're able to do something with it. The cost of failure here is very small. Matter of fact, we fail all the time. We break lots of stuff, but we're always failing forward and always trying to make our projects better and more interesting and fly farther and higher and pick up different objects. And so the FTC program starts in the 7th and 8th grade. The robots are Android phone based robots. So the kids are actually learning how to program their Android phone if they have an Android phone. And it's just a fabulous way to reach, teach, help kids take on a really hard challenge. And the team starts to become part of everything because no engineer is an island. Like you can't design a robot and drive it and do a business plan and figure out how to finance it. You need all these players to make a successful team, and that starts in the 7th and 8th grade. And so that's really satisfying. As you get into the high school, it really becomes exciting. And I'll turn it over to Hannah and Tony and Ryan and Devin, and they can tell you a little bit more about the FRC program, but it really is just a wonderful way to learn, a wonderful way to grow. We laugh a lot, and who wants to take it first?
Let's go with Hannah. Ladies
Hannah,
first.
I pass the ball to you.
Okay, so hi, I'm Hannah. I'm a senior. My role on the team is I'm head of programming, electrical, and pneumatics. So basically what I do is I make sure the robot works. So I program it. I have learned how to program in many different languages. Right now, I know how to program in Java, Python, C, C++, and probably HTML a little bit, but this has all been through the robotics program that I have had to learn these different programs and learn how these work. Like we do Java to make sure the robot works when we program it, but we also have this scouting app, which I developed, where we have to program all that in Python. So coming into this program, I knew how to program in Java, but I had no idea how to program in Python. So I had to learn that whole set and learn how to do it, create an app, and how to collect data, and how to make that into a Tableau file so then we could see the data. And that process took a while, but we were able to learn all that information. And one of the biggest challenges I've gotten was last year I had to do autonomous, which is pre-programmed code, which we launched just onto the robot and the drivers can't control it. We used this new program called Pathweaver, but it wasn't set up to work with the swerve drive, which we use on the robot, rather than a tank drive, which is just like how when you think of a robot, that's like the tank is the normal, while the swerve can like go back and forth from like side to side. So I had to orient the programming so it would work with our robot, and it took a long time, but I finally got it. But it was one of the hardest things I've ever had to do. And it was like you had to like move the little dots like one, and then it would go like across the room and slam into the wall, or it would go in the complete opposite direction. And it took a long time, but it was able to do it, and that hard work did pay off. I also work with Ryan on the plane behind us. So we come in every Tuesday and Thursday around 6:45 to work on the plane, and we get a little bit done every day. Yeah, and it's really coming together. When I started in 9th grade, I did not think that we would get this far, but we ultimately did. So Ryan, would you like to go next?
Yeah, sure. So as Hannah just mentioned, my name's Ryan. I'm also a senior. And on 12A team, I'm the head of our chairman's sub-team. I work on our mechanical sub-team. I'm also part of airplane building. So as Hannah mentioned, yeah, we do airplane building every Tuesday and Thursday. So we've been here since 6:45 this morning. And even though we're not getting a whole lot done, it is a very tedious process doing each individual nut and bolt and this and that. It's just been an amazing learning experience, and being able to work on an actual airplane, being able to say that we've been able to do that has just been an amazing experience. And working on our FRC team has also been super, super cool. As Mr. Ervin mentioned, some folks only know how to learn how to use a Phillips head screwdriver when they start. That was pretty much my boat. I've used a Phillips head and a flathead, and that's really about it. But as part of our robotics program, and as part of really our field building and building of the robot, I've learned all these different things and learned how to use all this complex machinery and learn how to create anything that we want to create. And it's just been a super cool experience.
So let's jump in with Tony. What can you explain what you are fabricating in the design and engineering class, honors engineering?
I would love to. So I came into this school in 9th grade. I hadn't had that much previous experience, and I've gone through the whole engineering track. I started with CEL with the microprocessors. 10th grade, I built an electric guitar from scratch for my capstone project. And now for my honors engineering project, I should say I'm a senior, I am fabricating a custom-built handheld game console using a Raspberry Pi. So what this entails is you have to 3D print all of the parts, and then that's the easy part. The difficult part is programming and getting the configuration right for the Raspberry Pi. That took me way too long. It took me like a month to flip the screen because I couldn't figure out what was causing errors. It entails wiring up all of the sound, getting an amplifier set up. I wired together all of the buttons, which is what most of this is. These are analog sticks. And now all I have to do is wire up the power system, which is the last step, and that's probably going to take me a long time too, but I'll figure it out. And so this has really been a culmination of all of my experience here. It's got a little bit of CAD and fabrication for the parts, and it's got a lot of electrical, which is something that I didn't even really intend to get into when I joined this team. I was thinking I was mostly going to be programming, and then I ended up switching to mechanical. And just over the years doing projects, I've picked up enough electrical that I can wire together something like this without it being too much of a hassle. It's got its moments of difficulty and frustration, but most of the time I'm just having fun making something for my own interest. This was just because I wanted a handheld game console, and I figured, okay, I'll just build one.
And Devin, would you take us home with a quick explanation as to why you decided to come here?
Oh yeah, of course. So I am this is my second year at SCH. I came here in 9th grade, and what really drew me here was the robotics program. I came into the lab, by the way, I'm sure you've noticed everybody here is still at SCH. I'm in a room on the other side. So everybody here is really dedicated to this team. I actually went into the room that everybody else is in right now, and I was just immediately blown away by the amount of projects that were there. I mean, there's really everything. They have drones, they have a go-kart that's hanging from the ceiling, they have a plane that they're still working on, and there's just numerous projects, and it just really blew me away. And it just kind of made me feel like anything is possible. Any idea I have can be done. And it was just kind of nice to know that I had the ability to come into this community. I also just want to say that both, or actually all three, Hannah, Tony, and Ryan have all taught me things. I'm in 10th grade and they're all seniors. And I just can't stress the importance. We have this memento, like every student is a mentor. And I can't stress enough how actually true that is. Hannah has taught me a little bit about programming. I still have a ways to go, but the fact that I have her as a resource is really amazing. Tony has been really great at helping me understand all the heavy machinery that we have in the lab and teaching me the different things that are necessary to actually begin to build different robots. And Ryan has done that as well. However, Ryan, like he said, he is the leader of the sub-team for chairmans, and that is a whole other part of the robotics program that has to do a lot more with like telling first, which is the program that we compete with, like what our team is. And he's been such a great mentor with that. So just wanted to give that little shout out.
Super. Thank you so very much. I'm going to kick it back to Dave and see whether there are any questions.
Yeah. Well, thank you guys. Thank you. That was very well said from all of you. We do have a couple questions. First question, and again, I throw this to the group. Do you offer prep courses before students enter the grade?
Interesting question. Yeah, we get about a third of our kids in upper school in ninth grade are new. And so we really start over in the beginning of middle school and the beginning of upper school with a sort of a zero base start. So we presume that everyone is new in ninth grade. And so that's one of the reasons why we start right off with the microprocessor course and the web development courses. We want to build those skill sets immediately so they can go on into CAD/CAM and designing thereafter. So we do not presume prior knowledge. We scaffold the kids that need it. And as Devin pointed out, we actually rely on our senior student body as teachers in this process. I have always felt that students learn more from each other than they'll ever learn from me. My job is to facilitate that process. And I think we do a pretty good job of that.
Okay, next question. What robotics or other engineering opportunities are available for ninth graders?
Okay. Ninth graders must take a CEL course, so that's not an option. They have to do it. I would recommend my course because I think it's a pretty cool course and a lot of fun. The kids this morning were starting to work on their final project specifications and getting pretty excited about it. So they're building all kinds of crazy electronic devices. That's one thing that ninth graders have not only the opportunity to do, but the obligation to do. They have to take one of those courses. And then the other thing is obviously we can start ninth graders in our upper school. Team 1218 is our upper school first robotics team. This year, we probably have about 20 new ninth graders that have joined the team. And you know, there's an awful lot of learning that has to go on. It's somewhat of a rebuilding year for all of the teams because there's not a lot of experience in the middle grades. Seniors were here when we were competing and constructing live, but juniors and sophomores have not yet had competitive on-field experience. And so there's a lot of opportunity to develop new skills. You know, I told our seniors as we came back to school this year, your job is not to design the robot. It's not to drive the robot. It's not, your job is to teach the freshmen, juniors, and sophomores how to program the robot. Your job is to be a mentor this year. And you know, I'm very proud to be able to say that they have risen to the occasion and taken that responsibility quite seriously, and have done a terrific job of taking on the role of technologically oriented mentor for each of the program elements within the robotics team.
And to elaborate a little bit more, Peter, I'm going to put you on the spot here. You compete, well, our Interact sports teams compete against 8 to 10 to 12 schools. You compete with somewhere between 5,000 to 8,000 teams worldwide.
The actual number is closer to 4,000 active teams.
Okay.
Yep, they're from all over the world. Most of them are in the US, but we do have teams from China. We have teams from Europe, South America. So it is truly an international competition. We've been doing this now for 20 years, Rob and I. And we've actually been quite successful at it. Our SCH robotics team has finished in the top 10 worldwide 5 times. It's second in the world, third in the world, fourth in the world, ninth in the world. And in 2019, we finished first in the world. We are part of an alliance from comprised of 2 teams from Detroit and 1 from the Netherlands. And it was our opportunity to stand on top of the podium. Pretty exciting day. 38,000 screaming fans at the Ford football stadium up in Detroit. Everybody who was there will remember it for a long time. Yeah.
So we just got this question. presented, do you work mostly in groups or is it mostly individual projects?
The answer is yes, both. We certainly have kids that work on independent projects that are their personal passion project. We actively encourage group projects. We find they are more effective. They're more fun to have a comrade in arms on a particular project, especially when the going gets tough. That's a useful support, and so we strongly encourage it. Every project that we do has the opportunity to go either way, so we're not prescribed individual. One of the nice things about what we get to do is, because we're all project-based, the concept of plagiarism really doesn't play into what we do. We want you to find resources. We want you to use those resources, improve on them, apply them, but we expect you to do that with academic integrity, but at the same time, we expect you to work together on those kinds of projects. Yeah.
So Hannah, you touched on this a little bit, but there's a question here that says, do you touch on Python at all? And I'm assuming that's also a question related to sort of the program languages that we teach.
Yeah, I can elaborate on that. So I don't think any of the curriculum that I've gone through so far has taught me Python. When I came in to start programming a scouting app, we decided that we wanted to use Swift first. And that didn't really work out because not everyone had an Apple device on their phone, so they couldn't all use it. So then we noticed that we should do Python in a sense. So we started from the basics. We started learning how to do it. I learned on my own. I went to do resources, all that, and I taught myself how to program in Python. And then from that, I make it a goal that every year I teach more and more of the freshmen and the underclassmen in how to program in Python, because as I've gone through, more and more people have told me that Java is not what you're going to need to know how to program in. It is going to be Python. So if I can pass on that advice, and I'm teaching Devin right now how to program in Python, and with the very basics about what an integer is, what variables are specific, what's public, private, and I go all the way through. I'm planning to go into college for computer engineering, so like everything I've learned from 9th grade and everything on, and it has basically been what I'm gonna do in college. So I'm passing on that information so people can go in the same path as me.
If Rob and I go back to the beginning, I think this is our 7th programming language that we've used in the robotics program, starting out all the way back with P-Basic and spending some time working with the National Instruments languages, and then moving on to Java, Python. The Arduinos we work on are programmed in a subset of C++. For those who are familiar with the old C, fairly close to the old C, sort of a bridge between the two. And we like these languages because they are very good building blocks in the educational process for people who want to be serious about programming in the future. And they're also very approachable. In the younger grades, we use Scratch as our primary programming environment. Our Lego robots are programmed in a variation on Scratch. And we use Scratch in our lower school program for introductory logic and programming. So variety of languages picked as a continuum. We are, despite the discussion on Python, we are heavily invested in Java right now, because the 7th and 8th grade robots and the upper school robots are both programmed in Java. And so, and if you want to do that at a very high competitive level, you need to develop talent early. And so we invest in that starting in 7th grade.
So the last question, and probably the one we get the most with admissions events and admissions tours, is obviously this is a huge time commitment for the kids. But do the students that participate in the team find time for other school activities like sports, theater, singing groups, clubs, etc.? And I throw that out to
Tony, take it away.
Actually, I was going to say.
Yeah. So not only am I a co-captain of the robotics team, I was a lead in the theater production of A Murder Is Announced. I played Inspector Craddock. I am in the honors a cappella group, it's actually a class. It's not as much of an extracurricular. And I also have time to take classical guitar lessons at home, and I still have some free time. So there's definitely enough time. Like if I really, really had wanted to, I probably could have squeezed in a sport too, but I didn't. There wasn't any sports I'm passionate about. There's definitely, you're able to make time. It can be hard sometimes, but like if you're really, really passionate about two things, you can definitely do them both.
And I think the important element there is that as a relatively small school, SCH compared to some of these large public schools, we depend on kids doing multiple things. And so as an institution, we have to make that possible. And we do that by being reasonable, being flexible. So for example, our upper school robotics team during competition season, starting in January, will meet 6 days a week. But we do not expect every kid to be there every day. We know that some of them have sports obligations, some of them have a cappella obligations, theater obligations, and we expect them to fulfill those obligations too. We want our fair share of their time when they're available and able to commit to doing what we need to get done. And I think this SCH does a particularly good job of making that possible.
Hannah, you want to add something?
Yeah, a lot of my friends like to say I'm a part of literally every club and activity the school has to offer. So if I'm doing all of that and I have time to do all my classes and stuff, there is time to do all of it.
Yes. And what Peter just said is the same thing you'll hear from the football coach, the play director, the sing group director. You know, we want our kids, we need our kids to do multiple things because as Peter says, a relatively small school, we need to. So first and foremost, thank you everybody for your time. You know, I walked in at 7 a.m. this morning. Peter and Rob, your cars were already here. Many of you students were already here working on the airplane too as well. I know you've had a long academic day and I really appreciate it. I came over here about a half an hour before this webinar and you guys were all in the robotics room tinkering on something, some project you were working on. So thank you very much. To those of you who were able to join us tonight, thank you very much for your time. We as admissions officers will be following up with you after this. If you have any questions whatsoever, feel free to reach out to myself. Peter's information and Rob's information is on the website too as well. Our website is also a great resource too to learn much more about what we offer from a curricular standpoint in clubs and activities. And once again, thank you for joining us and have a wonderful night. Take care.
Good evening, folks.
Thanks, Dave.